This is the Vexed Instructor and welcome to the channel. In this video, I'm going to derive the standard and general equations of a parabola. So stick around and let's see how it's done. Parabolas are a common conic figure in engineering that is used to manipulate how forces react in structures and to focus radio waves to a single point in space. Properly defined, a parabola is a curve whose points are equal in distance to the foci and directrix. As you can see in the illustration, if I were to draw a line from the foci, and let's call it point F, to any point on the curve which we will designate as point P, the distance that I would get would be similar in length to a line drawn from the directrix, which is point Q, to the same said point on the curve. Given that the length of a line is defined as the square root of the sum of the square differences of the change in the abscissa, or that would be the x-axis, and the ordinate, or y-axis, we begin by plotting the coordinate of the foci and the 2 points on the curve and directrix. You can see that I label the coordinate on the foci and the point on the directrix as small p. Small p is the distance between the center, labeled as point C at H and K, and the foci. Since the foci has the same height as the center, both of them have a y-coordinate of k. That would also be the same reason why the y-coordinate of point P and point Q are both y. As I said in the definition of a parabola, the length of a line FP would be equal to the length of a line QP. So, substituting the correct point into the proper variable in the equation of the length of a line, we find that the square root of the quantity x minus h plus p squared plus the quantity y minus k squared equals to the square root of the quantity x minus h minus p squared plus the quantity y minus itself squared. After which, I can simplify the last term on the right-hand side of the equation to a 0. Then, I square both sides of the equation to remove the radical sign, and distribute the subtraction operation into the grouping of h plus p and h minus p. This will give me the equation, open quantity, x minus h minus p, close quantity squared, plus, open quantity, y minus k, close quantity squared, equals to open quantity, x minus h plus p, close quantity squared. If I'm going too fast for you, feel free to pause the video now and review how I did the process step by step. Before I continue, I need to take the square of the terms x minus h minus p and x minus h plus p. But to do so, I'm going to use a technique called the Punnett Square. To start my Punnett Square, I'm going to write down one multiplier at the top of the square, with the other multiplier on the left moving down term by term. Next, in each square in the middle, I'm going to multiply the term on top with the term on the left like so. I continue to do so in a systematic manner until my Punnett Square looks something like this. Use the same technique to square the x minus h plus p term. To get your answer, just add all the quotients together and combine like terms. Again, pause the video here and do so on your own. If you have any questions on how I did the Punnett Square, place them in the comment section below and I'll get back to you. We continue solving for the standard equation by putting the results of our Punnett Square in place of the squared terms of x. I identified like terms in red so they can be cancelled out. Next, I transposed all the terms not related to the y variable to the right-hand side of the equation, then combined like terms again. Lastly, I factored out 4p from both remaining terms on the right-hand side of the equation to finally get the standard equation of a parabola. Take note that the derivation we just made was for a parabola opening to the east of a Cartesian grid. So, When you're working with other types of parabolas, you can use these equations. Notice that the change in x and the change in y trade places when the parabola is pointing from the east going to the north. Finding the general form of each parabola is easy. We begin with the standard equation and us distributing the 4p multiplier. Coincidentally, if you are asked to find the latus rectum of a parabola, the equation is 4p. Next, I expand the binomial, open quantity y minus k, close quantity squared, and transpose everything to the left-hand side of the equation. The result is a general equation of a parabola opening to the east of a Cartesian grid. For other parabolas, I took the liberty of solving them for you here. I hope this video helps you to understand how the equation of a parabola came to be. I'd like to give a big shout out to St. Anthony's School Manila for providing me a place for me to do my recordings. And if you like what you see, don't forget to click that like button and subscribe to help the channel grow. You can also leave any curiosities or suggestions as well in the comment section below. I hope to see you all in the next video. Any questions?